Hello everybody, I'm going to be writing out all of these steps in the Michaelis-Menten equation. So, first part is kind of this first step of the reaction, which is doing our enzyme and our substrate together. And arrows go both ways. And then the second part is our enzyme and our substrate breaking apart to give us the enzyme and the product. And then when you add the two reactions together, our net reaction would give us our substrate and our product. And then, so from this point, we need to assign the rate constants for the rest of our equations. And so this forward part, we label K1, the backwards arrow is going to be K negative 1, and then this forward arrow will be K2. So when we look at it, this K1 is basically creating this ES, whereas this K negative 1 and K2 are consuming the ES. And so this next step, we're writing this. And this reaction is basically a really long reaction saying that K negative 1, so this forward reaction minus K negative 1 minus K2 equals 0. And there, equals 0. All right, so we have that long reaction, and then the next part we have to kind of, with this K1, our reactants for K1 are E and R S, and so it's hard to determine kind of the value for this unbonded E, and so they use this equation, which uses this ET, which is kind of a new value here, and so we put our E plus concentration of E and our S, and so we're trying to figure out the total concentration of our enzyme, and so this ET stands for basically our total concentration of enzymes, and we're left with our E Alright, so here we want to solve for E. So divide both sides by the ES to get our E, and then so we basically, the next step, we want to put this ET part into this top formula part of the equation, and so start to write that out. So here's our ET minus our ES, and then times our S minus our K negative 1 times our ES minus our K2 times our ES. Alright, so we have our ET, so our total enzyme concentration plugged into that formula. So the next step is we want to distribute the K1 and the S into the first term. So we're going to, we have our ET minus ES times our S minus K1 times ES minus K2 times ES. Alright, so after we are distributing our K1 and our S, we are going to be left with 0 equals K1 times ET times S minus K1 times ES times S minus K negative 1 times ES minus K2 times ES. So at this point, we are wanting to solve for the ES, and so we want to try to get all of our ES's to one side. And so we have ES K1 times S plus K negative 1 plus K2 and equals K1 times ET times S. So we have our ES on one side, and now we just want ES by itself, and so we have our ES by itself on that side, and it would be times K1 times ET times S all over K1 times S plus K negative 1 plus K2, and you're going to multiply this times 1 over K1 over 1 over K1. So from that, final formula for ES, to solve for ES, it's going to be our ET times our substrate all over substrate plus K negative 1 plus K2 over K1. And from here then, so for this next step, we want to figure out the rate of the change for now this P now for the products. And this is the formula for that. So K2 times our ES, and we just kind of figured out this formula, goodness, I can't talk, formula for ES. We can actually plug this formula in here, and that's where we get our Michaelis-Menten equation. Goodness. And so that equation is V, which stands for velocity. And we have our dP. And then here they wrote kcat, and we have our ET times our S over our S plus Km. So they have this reaction. They write it different. So kcat, we kind of learned, is basically the same. It means the same thing as our K2 that was written on that formula before, the K2 times our ES. So the K2 is the same as this kcat. And so this kcat or the K2 basically stands for the maximum or the total number of molecules that an enzyme can catalyze per second. And so we have this, and then they also point out that we have this ET, which is the total concentration of enzymes. And so basically both of these together equal to Vmax, which is our maximum rate. And so from that we can write our another equation, which is this. So in the end we'll learn this is kind of the end, but we also kind of want to talk about Km. So this Km is basically, put it in parentheses, our K negative 1 plus K2 all over K1. And so in the video we watched, he kind of brought up the question, you know, what if the concentration of our substrate was actually equal to this Km number? And we wrote another equation saying this Vmax times S, and now these two S's would cancel out, leaving us basically with Vmax divided by 2. So this Km is basically the concentration of our substrates at which the rate of half of this maximum velocity. And so this is equation there.